Hello, geometry. This is 2.5. We just finished the algebraic proofs, and now this is going to be our first lesson on geometric proofs. So there's several different variations that we're going to see over the next two lessons. This one is going to use something called two-column proofs, and we'll see that on page 54. How we have the statements of something that we're wanting to prove. The statements are going down the left, and we have reasons that we have to come up with the right. Okay, these reasons have to be definitions, properties like the subtraction property or multiplication property, addition property, postulates, okay, like the point line postulate or the plane intersection postulate. And new this one is we're going to get theorems, okay, and theorem is going to be something that you can prove. Postulates are something that can be accepted without proof. We'll write this down later on as well. Theorems are something that you can prove using some definitions, properties, and postulates. So a proof is a logical argument that uses deductive reasoning. Remember, deductive reasoning uses the definitions, properties, and postulates to show that a statement is true. So there'll always be some sort of given. So our given here is that AC, the distance from A to C, is the same as A plus B plus A plus B. Okay, so it's 2 times this. So we kind of know, hey, B must be a midpoint because BC has to equal AB. But that's what we want to prove. We can think about that and know, okay, these two must be the same, but we want to prove it. So on a proof, we have our statement. The first statement is pretty much always the given, and that's the reason. It's what you know for sure because it's been put into the question, the property that you have. So we have AC equals AB plus AB. So we come down here to statement 2. AB plus BC equals AC. And a lot of times we ask the question why, or what's changed, what's different. So A to B plus B to C equals A to C. So A to B plus B to C equals A to C. So that's telling me this distance plus this distance has to equal the total distance. Okay? That is the segment addition postulate. And by this time, hopefully I've given you a chapter summary that's going to list all these rules and properties and postulates that we've had so far, so you can look at that. So a segment addition postulate, when you add the two segments together, it equals a total. So step number 3, we ask, okay, what's different? Why is this true? Why is that true? So I look at step number 2, and it looks like AB plus AB equals AB plus BC. So this part is the same as this part right here. So it looks like this part has changed. So there's a change there. Why could we do this change right here? Why does AC equal AB plus AB? Well, that's because of our given. So when two things are equal, you can substitute one for the other. So this will be our substitution property. When two things are equal, you can substitute one for the other. So substitution property is the reason why we can do this step. And now we have AB equals BC. So we look up above, I have AB plus AB equals AB plus BC. So the BC is there and the AB is here. Notice these two are gone. Well, those are the same thing. They've been added, so it's almost like they subtracted it from both sides and it canceled off. So if you subtract something from both sides of an equation, that is the subtraction property from last lesson. Okay, so we've just done our first proof, stating the reasons for our first proof. Statements go on the left, and the reasons go on the right. Okay, so here, this kind of goes on into this page here, onto page 55, but here's the diagram. Okay, 6 steps of a proof are shown. Complete the statements that correspond to each reason. Here's our given. Measure of angle 1 equals measure of angle 3. So you see the arcs there? 1 and 3 are the same. They want us to prove measure of angle EBA equals the measure of angle CBD. So EBA, that is 2 plus 3, equals CBD, that's 1 plus 2. So your brain should already be kind of going, thinking, okay, what do I have to do to prove this? So they want to know this big angle right here and this big angle right there. Well, if 1 and 3 are equal, both of those angles add 2. 2 is the same thing. That's how we're going to prove it. So they filled in the reasons. Now we're going to fill in the missing statements. So the first reason is given. Well, our given was measure of angle 1 equals a measure of angle 3. So that's what we put in there. Measure of angle 1 equals a measure of angle 3. Okay, they use the angle addition postulate. EBA is 2 plus 3. They use the substitution property of equality. So it's the substitution property, and since 1 equals 3, 3 equals 1. So they substituted those two. So the measure of angle EBA equals 2 plus 1. So here's another blank we need to fill in. Measure of angle EBA, and they're saying it's the commutative property of addition. So commutative property, you may have to look up some of these sometime to remember what they are. That says A plus B equals B plus A. So if they're using that property, we're just going to switch these around right here. Measure of angle 1 equals the measure of angle, plus. Measure of angle EBA equals the measure of angle 1 plus the measure of angle 2. And that's the commutative property. Just switch the order in which you add. Okay, measure of angle 1 plus the measure of angle 2 equals, angle addition postulate. So these are two smaller angles, and they have to equal a bigger angle. So 1 plus 2 equals CBD. CBD. So that equals the measure of angle CBD. Angle addition postulate. Okay, now they use the transitive property of equality. Sometimes substitution will be used in this case. Transitive and substitution can kind of look similar at times. So what they're saying with transitive is if EBA equals 1 plus 2, 1 plus 2 equals CBD, then EBA has to equal CBD. You can also think of it as a substitution because EBA equals 1 plus 2. You can substitute 1 plus 2 with EBA. So just be aware of that. If you're looking for a substitution property on your drag and drop when you're doing the assignment, it may not be there. It may actually be a transitive property. Okay, so if EBA is 1 plus 2, 1 plus 2 is CBD. The final step is always what you want to prove. What do we want to prove here? So the measure of angle EBA equals the measure of angle CBD. Okay. Okay, let's see what other practice we have here. We got 3 other proofs to practice on, so let's keep going here. Okay, so we already talked about a proof. It's a logical argument. Okay, so we're going to say it's going to be statements and reasons. Statements and reasons that prove an argument. Argument is just a given and what we want to prove. Okay? So 2-column proof. These are going to be numbered statements, and they go on the left. And corresponding reasons, they go on the right. That show an argument in logical, there's that word logical, order. Okay, show an argument in logical order. Okay, so theorem. Theorem is just a statement that can be proven. Statement that can be proven, so we can use a proof for it. Okay, compare that with a postulate. This is a postulate is accepted. Accepted as true without proof. Accepted as true without proof. That's a postulate. So some additional properties that will come into play here: reflexive, symmetric, and transitive. Okay. So reflexive property, remember, it has a reflection. Symmetric property is symmetric across the congruent sign. Remember, this is the congruent symbol. Okay. So reflexive, symmetric, and transitive for segments, and reflexive, symmetric, and transitive for angles. Okay, all of those work together there. Make sure you look through those, understand each one. Those properties you've seen for a number of years now. Okay, so we're writing a two-column proof. These are the notes. You need to pause and just kind of read through that. I'm not going to read it to you right now. They kind of give an explanation of how we go through this process here. Okay, so go ahead and pause. We'll go down to extra practice down here and work on filling in these missing items. Okay, so exercise 1. Number 1 here, notice here's our given. We have segment AB and segment CD bisect each other at point M. Okay, they've drawn the lines K and L, but they're saying segment AB and segment DC bisect each other at M, and so BM is congruent to CM. So we know this is congruent to that. So notice how I put that symbol down there. When you're doing these on a computer, maybe you will want to write these examples down, draw them out on paper, put any labels you can on there. Okay, that's going to help you moving forward. They want us to prove that AB equals AM plus DM. So AB equals AM plus DM. So there's our final statement here. That's what we want to prove. So here's our given. BM is congruent to CM. Here, number 2, CM is congruent to DM. So why do we know CM is congruent to DM? Well, remember, if they bisect each other at point M, that makes M, we know that is a midpoint. And if that's the middle, it has to be the two sides are on either side. So I'm going to put here that this is a definition of a bisector. Definition of a bisector. Or maybe you can say definition of a midpoint. Okay, so one of those options might be there. Third step, BM is congruent to DM. Okay, so BM is congruent to DM. Now we don't have anything on our diagram about that. There's two different lines, so let's look at our other properties here. We said BM is congruent to CM. CM is congruent to DM. So then it went BM is congruent to DM. So it took this step and said, okay, if A equals B and B equals C, then A has to equal C. So this is again where you can use the transitive property, or it could be a substitution. Now they're probably going to get even more specific and say transitive property of segments. Transitive property of segment congruence is probably the name they'll give it there. But just transitive property is good for right now. Okay, so let's look at 3 to 4 here. What changes here? This is a segment. Segment BM is congruent to segment DM. This says BM equals DM. Now remember, without a symbol on it, this is referring to the distance from there. And this is important here, okay? Distances are always equal. These are objects. Objects are congruent. Distances, this is a number. This is a number here. This is a distance. It's a number. Numbers are equal. Objects are congruent. Okay, but notice it's exactly the same. What's going to happen here, this is the definition of congruent segments. Definition of congruent segments. Because if two things are congruent, then their lengths are equal. Their lengths are equal. Okay, so segment addition postulate is our next reason. We have BM equals DM. So we know this length from B to M equals length from D to M. And here, notice AB equals AM plus DM. So something about AB. I'm going to say here AB, A to B, equals AM plus BM. AM plus BM. So distance from A to B, we're getting into our final step here, equals AM plus BM. So if BM equals DM, we can substitute, this would be more what the substitution is, substitute BM with DM. So I'm going to bring this one and call this one the substitution property. Transitive doesn't work as well here. That'd be a substitution property. Okay? So always asking yourself what's changed, what's different, what properties do we have? Look at your charts, look at your back in the lesson, what property, how can we explain this? Okay? So given, two more examples here. Given angle AEB is a complement of angle BEC. Remember complement. Whoops, there we go. There we go. Now we can see it. Sorry about that. AEB is a complement to BEC. So that means these two have to be right angle. So notice I put little notes here to help me along the way to see what's going on. So they filled in the given for us. So 2, this says definition of complementary angles. Well, the definition, if you don't know it, look it up. But it means if two angles add up to 180 degrees. Their measures do. Okay, notice this is a measurement. Measurement is a number. Numbers are equal. If I just say angle AEC, I'm talking about an object. That would be congruent. So since we're dealing all with measures here, I'm going to say the measure of angle AEB. So AEB plus the measure of angle BEC has to equal 90 degrees. That's the definition of complementary angles, two angles that add up to 90 degrees. Okay, so what's changing here? Measure of angle AEC equals the measure of angle AEB plus measure of angle BEC. So what changed is these two have stayed the same, and they made the 90 degrees into the measure of angle AEC. Okay, so we have the measure of angle AB plus measure of angle BEC. Got it. I got it here. So measure of angle AEC equals these two angles added together. That's going to be our angle addition postulate. Should have just looked at the diagram. AEC equals AEB plus BEC. So the two smaller angles added together equal the bigger angle. So here we go, AEC equals 90. So AEC, notice these parts are the same, that and that. So if this equals 90, if 90 equals AEB plus BEC, and AEB plus BEC equals AEC, that is the transitive property showing up again. Favorite property, transitive property. Okay. So here we have AED, measure of angle AED, plus the measure of angle AEC. So AED, AEC equals 180. Definition of supplementary angles. We can say that because we know this is a line, and so they have to add up to 180 degrees. Here we have the substitution property of equality. So AED, we know AED plus AEC equals 180. Substitution property, AEC equals 90. We're just going to say measure of angle AED plus 90 degrees equals 180 degrees. So the final thing that happened is they subtracted the 90 from both sides. So we're going to call this a subtraction property of equality. Okay, exercise 3 and 4. Name the property that the statement illustrates. This goes back to a lot of these properties are going to be the ones that are on page 56. Okay, so this goes back to these that are on 56. Reflexive, symmetric, transitive. Okay, so if RST is congruent to TSU and TSU is congruent to VWX, then RST is congruent to VWX. Transitive property. Okay, of angle congruence. So keep in mind they may have two transitive properties. You want the one that's of angle congruence because you're dealing with angles. Okay, don't let that trip you up. Okay, if GH is congruent to JK, then JK is congruent to GH. Okay, that's just symmetric on both sides. There's symmetry there. This is the symmetric property of segment congruence. All right. And here we go. Last example here. Oh, there's no steps. How are we going to do this? So we're at a two-column proof. M is the midpoint of RT. M is the midpoint of RT. They want to prove MT equals RS plus SM. Okay, so in your brain you should be thinking, well, of course it does. That's the middle, so these two sides have to be equal. And if you take these two, add them together, that should equal the total side. That's right, but we have to prove it. Why is that right? Okay, we just can't say it and accept it as truth. We're going to prove this. So the first step is always the easiest. It's always going to be our given. Okay, so we're going to say M is the midpoint of RT. M is the midpoint of RT. That's our given. So from that, what do we know? And sometimes you start somewhere and you may not get there. This is where it's very important to just be persistent and keep trying. Proofs may have different steps for different people, depending on what properties and what theorems you remember. So if M is the midpoint of RT, what does that tell us? Well, that tells us that RM is congruent to MT. So RM is congruent to MT. And I'm going to say that's the definition of a midpoint. A lot of those definitions and rules, you want to refer back to something that you had in the previous step. The previous step talked about midpoint, so it's going to be some sort of definition about midpoint. Okay, I noticed that I want to prove distances. I want to prove something that represents numbers, and these are shapes. So I'm just going to say RM, the distance from RM, equals the distance, that should have a segment on it, from M to T. Okay, that's going to be my definition. These were congruent segments. This is my definition of congruent segments. Definition of congruent segments. Okay, so here's my MT that's showing up there. RM, like, okay, well I know these two add up to RM. So I'm just going to put that RS plus SM equals RM. That would be our segment addition postulate. The two smaller parts add up to the total. So if RM equals MT and RS plus SM equals RM, that means RS plus SM equals MT, which is what we wanted to prove. That was, again, our transitive property. You can make a case it is a substitution, but I think transitive is normally the one that they're going to accept there. Okay, so these are the lessons that are definitely helpful to do your homework in class. So I hope you've watched this. It'll give you an idea. We're definitely going to work through this together a little bit as you get in here. If you have questions, I'll be available for you. And we'll work on our geometric proofs. Good work. See you tomorrow.